Hello guys, welcome to Crown's Math. In today's class we're going to be doing differentiation on product rule. So we're going to use product rule to differentiate a function. Now when we use product rule, we use it when we have different functions multiplying themselves. Whenever you have two functions multiplying itself, we use product rule. So now we have the first question that says f of x is equal to this. Sorry I did it this way. I was supposed to write f of x equal to this, but there is no problem. Let's continue. Now to differentiate this, to find f prime of x, we have to use the formula for product rule. Now let f of x be u of x times v of x, just like what we have here. We're having this function times this function, so we call this function u of x and we call this function v of x. So the product of these two functions gives f of x. Okay, so we let u of x to be this and v of x to be this. Then the f prime of it is v of x times, you differentiate your u of x, plus u of x times you differentiate your v of x, and this is what you have. You have v of x times u prime of x. If you differentiate u of x, you have u prime of x. If you differentiate v of x, you have v prime of x times this your u of x. Now you sum everything up. So that is the formula. This is just the formula. You can use this or you use this, whichever way is okay for you. Now let's solve the question. Now for number one, let me write the solution. For number one, we have our f of x is equal to 2x plus 4, and we have 3x squared plus 4. Now let our u of x equal to, let me take this as my u of x, 2x plus 4, and let me take the other one, v of x, to be equal to 3x squared plus 4. Now our u prime of x will be, remember this is a polynomial. Let me just use, this is a linear equation still under polynomial, but remember differentiating a function, especially when it's a polynomial, we use the formula a(n)x n minus 1. This is the formula for differentiating f prime of x. Okay, so when differentiating this, we differentiate it term by term. Okay, so u prime of x will be, this will be, if you differentiate 2x, you have 2. Now if you differentiate 4, you have what? 0. 4 is a constant. Okay, so differentiating a constant is 0, so this is equal to 2. Now v prime of x is equal to, now if you differentiate this term, you have 6x raised to the power of 1. Some of you might be wondering how. This is, you multiply the power and the constant here. 2 times 3, 6. Then you write the 6x. Then what you do is, the power is 2. 2 minus 1 will give us 1. Now plus 4 here is a constant. Okay, so it has no x multiplying it, so it's just a constant. Now if you differentiate a constant, what do you have? 0. If you check my other video, you will see, check my other video where I posted on differentiating a polynomial, you will see where I show that to differentiate a constant is 0. Okay, now we are done. We have our u of x, we have its prime, we have v of x, we also have its derivative. So we are going to make use of this formula. So our f prime of x is equal to, now what is our v of x? 3x squared plus 4. Okay, multiplied by, what is u prime of x? 2, plus, what is my u of x? 2x plus 4. What is my v prime of x? 6x, multiplied by 6x. Okay, so if I want, I can expand this, but this looks easier, so let me expand it. So if you open this, you have 6x squared plus 8, plus this will give us 12x squared, plus this will give me 24x. This is equal to what do I have here? 12 plus 6, 18x squared plus 24x plus 8. So that's your answer. Okay, over to the second one. We use the same rule here. Over to the second one, we want to find h prime of x. Now let me write it out here. My h of x is equal to, this is x squared plus 1. Let me write it one by one. X squared plus 1. Okay, and we have half x raised to the power of 4 plus 5x squared. So I have half x raised to the power of 4 plus 5x squared. Okay, now we want to differentiate this using our rule v of x dot u prime of x plus u prime of x dot v of what? No, u of x dot v prime of what? X. That dot is multiplication. This dot here is multiplication. So using this formula, we say, okay, h prime of x is equal to, first of all, let's take our u of x and our v of x. I will take this to be my u of x and I'll take this to my v of x. So my u of x here is x squared plus 1. My v of x here is half x4 plus 5x squared. Okay, now my u prime of x is 2x, and my v prime of x, remember how I got 2x? 10 by 10. This is a polynomial, so 10 by 10. 2 come down here, 2 minus 1, you have this. Differentiation of a constant is 0. Now this is the same thing as 4 over 2x3 plus 10x. Okay, now this is equal to 2x3 plus 10x. Now using our formula, what is our v of x? Our v of x is h prime of x is equal to half x4 plus 5x squared. Okay, let me put this as h prime of x, okay, so that it won't confuse you. Now what is our u prime of x? Our u prime of x is what? 2x. Okay, now we have here as our v of x, no, our u of x. Our u of x here is what? X squared plus 1, and our v prime of x, remember they are multiplying each other. Our v prime is what we, anytime you hear prime, it's differentiation. So our v prime of x is 2x cubed plus 10x. Okay, that's it. Now you can still simplify this if you want. You just open the bracket. Okay, let's open the bracket for this video. So we have this as if you open this up, you're going to have 2 multiply this, 2x multiply this, 2x multiply this. So 2x multiply this, we are going to have x5. Okay, plus we are going to have 10x3 plus, now to open this one, this multiplies this to, we are going to have x squared multiply this, we are going to have 2x5, x squared multiply this, we are going to have 10x cubed. Okay, plus 1 times this gives 2x3, 1 times this gives 10x. Then I collect like terms. Okay, so we are going to have this as, okay, this is x5, so 1x5 plus 2x5 give us 3x5. Okay, this one has x3, x3, x3. So 10 plus 10 give us 20 plus 2, that is 22x3. Okay, what again? Plus we have 10x. So that's all, we are done. So that's how you enjoy the video. Please do not forget to subscribe, and please, if you don't understand, please rewatch this video, please. Thank you very much. Please subscribe.